All right, welcome everyone. Thank you so much for joining today. We are going to be learning some excellent insights about thermally modified wood from Lisa at Maximo. Helen and I were just lucky enough to get some of her expertise over the past 15 minutes, so I'm really excited for today's presentation. Lisa has a wealth of knowledge to share. Today is an AIA-approved course, so we ask for AIA numbers upon registration. We'll also send over a form momentarily in the chat where you can submit your AIA number and a certificate request there in case you're worried that you didn't do that upon signing up. Before we go ahead and get started with the CEU approved portion of today's webinar, my colleague Helen is going to give a quick little intro about Acelab. We're helping out with hosting today's event, show you guys how to access some of our free tools and resources there, as well as how to get in touch with Lisa directly if you have some questions after today's webinar. So we'll start off with that, and then we'll continue with the CEU course. Helen, whenever you're ready.
Awesome. Sounds good. Hi, everyone. Happy Thursday. I'm Helen, and I'm the Director of Architect Experience here. My job is to make sure y'all have a great time on the platform, find what you need, and are supported in everything you need for your project. So quickly today, I'm going to talk about what to expect after the webinar and how to get in touch with Lisa. And then last but not least, I'm going to show y'all some things that are coming up and see if any of y'all are interested in early access for that. All right. So first and foremost, one quick note for y'all. The AIA certificates and submittals to the AIA, that happens usually about 10 to 14 days after the webinar. So do keep that in mind. What'll happen after this is that my colleague Evelyn is going to go through and she's going to be making a conversation for you. You can access that conversation by going to Workspace and then clicking Conversations here. She will connect you with Lisa based on what you fill in into the poll, like I'm looking for product literature, technical information, whatever that is, she'll make that clear. And that allows you and Lisa to kind of take the conversation from there. I do really encourage folks to respond. And even if all you're here for is just the CEU credit and maybe some product information, we'd still love for you to respond to Lisa so you have her information. And if a project comes up down the line, you're ready to go and you have the education that you need. That being said, let's go ahead and talk about how to find Maximo on the Acelab platform. So up here in the search bar, you can always search for a brand that you might be looking for by going to brands, and then you can click on the name there. So here is your contact button to get in touch with Lisa. Again, we'll be creating a connection for you, but if down the line you have something else you want to reach out immediately after this presentation, feel free to do that. Again, it'll start a conversation in Acelab. And so here's a little bit more about their process, and scrolling further down, you'll be able to see their products as well. So that is what this page looks like. And what I want to talk about next is some things that are coming. So currently, if I was back on Maximo's page here, I would save their products in and I could create a really beautiful comparison. We have a team of folks that spend a lot of time putting together apples to apples comparisons based on your different categories that you're looking at. So for windows, we're going to be comparing dimensions, glazing packages, different types of glazing you can get with those options. Your whole team can leave comments, you can upload documents. If BIM, CAD, or spec files are publicly available, you'll see those here too. So this currently exists in the platform. It's a really fantastic time-saving way for your entire team to say, hey, I'm looking at 4 to 5 different products. Which one's the best one for me? So this is already here. What's coming out soon is the ability for everything you have in comparisons to then jump into a schedule. We will organize those again by category here. A couple of things about this. First and foremost is all of these columns are custom. So you can set these up how you want to. There's the ability for you to have maybe an internal working review where you're going to have the previous projects the item was used in, the different reps that you speak with, additional kind of information, which office is using this product. And then you can turn all those off and you can export just the ones maybe back here that are a bit more important for your documentation needs. So you could take that as a CSV and drop that into your file there, your drawing set. Also, we have the ability here for you to add a placeholder product. We have 35,000 building products right now on Acelab. We're hoping to have 100,000 by the end of the year. But with this, even if we don't have the product, you can still have the ability to add something and ensure you have a complete schedule across all your different categories. Last but not least with this, you'll have the ability to, let's say I love these 3 products that I used on this project, have another one I want to use them on. You can select them here, and then you'll be able to move those into your next project. So really nice kind of copy and paste functionality there. This is coming out in September, but we are offering early access for folks starting this summer. So that's on a rolling basis. And what we're really looking for folks to join us in early access is opinionated folks, folks who want to tell us how this can work for them, and what they kind of need, what they like, what's working, what isn't. And also with this, you'll be getting the expertise of our team to build out your library for you. And that can be very helpful also. Anyways, on the heels of this too is a little to-do list for y'all that'll come out as well. It'll preload all those products and let you know, like, hey, we still need to figure out what our metal shingle choices are going to be. So this will come out in September, but if you want to join for early access, I'd love to meet with you, hear about your firm, and get yourselves going in Acelab and really this kind of robust usage here that we hope will save you a lot of time. All right, thank y'all.
All right, awesome. Thank you so much, Helen. Appreciate you giving the quick intro and showing folks how to reach Lisa. If you are interested in learning some more about how to use Acelab or gaining early access to some of our newer tools, we have a poll up right now. Feel free to submit a yes to that, and someone from Acelab's team will reach out to coordinate a quick call with you. And also Helen will send over her meeting link in the chat momentarily. So if you want to book a time on your own, feel free to just grab that link from the chat and set up a time with Helen. All right, few quick housekeeping items for me. In case you joined a bit late, we did ask for AIA numbers on registration. So you probably submitted it there, but in case you're worried you didn't, we're going to send over a form in the chat momentarily. You can let us know your AIA number and you can request a certificate through that form. Other than that, I just want to encourage folks to please submit any questions to the Q&A throughout today's presentation. We'll keep our eye on those if anything is super urgent. We'll hopefully get to some live questions at the end of today's event. And if we don't get to your question live, we'll have a record of it so we can follow up with you after today's webinar. All right, that's it for me. Lisa, whenever you're ready, feel free to go ahead and get started with today's webinar course.
Oh, okay, I am ready. I think what I'm going to do is take my video off though to save, so it won't have issues, but I am just trying to figure how to share the screen.
There should be a green button with an arrow that says share screen wherever the rest of your Zoom controls are. So it might be at the bottom or the top.
I know. And what's so crazy is it's, let me look at the top because it's normally at the bottom, but it is not, there's nothing saying show screen. Let me see, maybe I'm missing something. Yep, I got it. So sorry.
All good. Sometimes it hides it if you don't have Zoom all the way expanded.
And that's probably what happened there. All right, so is everybody okay if I turn the video off on me? I'd rather you look at the course than me.
Sure.
All right, perfect. And of course, now there it goes. All right, let me put this on presentation mode. Can everyone see the presentation okay?
I can see your screen, but I'm still seeing the full PowerPoint slide.
Okay.
So
okay. Hopefully that worked.
Yep.
Oh, thanks, Bo. Thank you, everybody. And welcome to this course today. I hope to make it educational, informative, and somewhat entertaining. It's a course that is really near and dear to my heart. I have been in the wood business for a long time and just love all things wood. Today, we're really going to talk about something called thermally modified wood and how it can really be used in the design environment as a sustainable product, as a biophilic product. And it's just a great choice. I normally ask a poll question, how many people have heard of thermally modified wood? A little bit different, difficult to do in the webinar, but that's okay. So that this is an AIA CEU approved course. There is my provider number and course number. Also, it is credited for one CE course. And then we'll get right into the course description. Today, what I'd like to do is just go over thermally modified wood, everything from the raw material selection to the manufacturing process to how it's used in the environment. We will go through a section on biophilic design. And then last but not least, we'll just talk a little bit about some fastening and how do you store it and that kind of thing. So what I hope that you will leave here today with is understanding thermally modified wood and the modification process, and what makes this particular process that we're doing different from others. Also, learning about the species and why are the species selected for this. Understand the environmental and biophilic benefits of thermally modified wood. Then we'll look at some architectural applications in the environment, siding, cladding, rain screen, and last but not least, as I mentioned, just proper storage, handling, and finishing. So, what is wood modification? Well, let's just say that there are a few different modifications out in the marketplace today. And I will back it up and say this is different from a wood treatment. Bo and Helen and I were talking prior to the start of the class, and I always like to make sure that I talk the difference between a wood treatment and a wood modification. Basically, a wood treatment, you are surface treating the edge of the wood. It's not reacting all the way to the core, and it's certainly not changing the wood's molecular or chemical structure. It is literally just treating it. The core is left untreated, and you know what happens to anything, especially wood, when left untreated at the core? Moisture will find its way into that center and then start reacting and degrading from the inside out. So big difference between wood treatment and modification. Modification is going to alter typically it's mostly softwoods, but there are some hardwoods that take this process, but it is going to alter it permanently at the cellular level. So there are three types of wood modifications really out there on the marketplace. There are the thermally based processes, which we will talk about today. There are chemical processes that change the chemistry inside the wood typically at the cell structure. And then there are physical processes, and that typically involves what we used to term sort of polymerizing the wood, where it would insert a resin that would bond with the cell wall. So for today's purposes, we are going to talk about thermally modified wood. And when we talk about thermally modified wood, this is typically, if we were live, I would ask how many of you have heard of it, and find out that if the trend seems to be changing. 5 years ago, I'd get 20% had heard of it, 80% not. It seems like the last few times it's been 70% have heard of it and 30% have not. Well, what I like to point out here is that this is not anything new. It, in fact, has been used in many societies. Certainly in Japan, they have been doing a process called shosugibon for hundreds of years, which is basically charring the wood or burning it to make it last longer and make it stable. And then certainly, you know, again, talking to Bo prior to the class, we know that the Vikings were using a system of heating wood to create their Viking ships. But fast forward to the 1900s, a wood scientist, Dr. Callum Hill, who is out of Bangor University in Wales, who has done extensive work on wood modification, actually found that the first documented paper on thermal modification appeared in 1911. And it appeared in the Forest Products Laboratory, which is in Madison, Wisconsin. Part of the University of Wisconsin works pretty closely with them. And it's really a research division of the U.S. Forest Service. So isn't that interesting that papers have been written on this process since 1911, and here we are some 113 years later, and we're just talking about it on a commercial level. When you talk about the manufacturing process and how thermally modified wood is created, there are really 3 steps, and that's it. That's what I love about this modification process. It's 3 steps, but it's not simple steps. You've got to really have I'd like to say that it's an art and a science, because what you're doing, you're going to stack and sticker boards, as you can see here. Get ready to insert them in a very large vessel or kiln where the temperature is going to be increased. Now it's going to be increased to a very hot temp, and this is in Celsius, anywhere from 212 to 230 degrees, which is all dependent on species. One species, they have found the magic happens around 230 degrees. Other species closer to 212. This is done over an extended period of time. It's not like a couple of hours or 3 hours. It's done a fairly lengthy amount of time, because they're slowly increasing this so that the boards have time to start acclimating to the increase in temperature. Once they have found that the boards have reached the temperature, the desired temperature for that particular species, that temperature is held for 2 hours. And that becomes sort of the magic. So within those 2 hours, that's where all this thermal modification is occurring, basically. So when at the 2 hours, they're looking at it and they're controlling the temp, they're measuring the moisture content. And when the moisture content is essentially zero, so they removed all the oxygen from the kiln, they then take the third stage, where they start lowering the temperature very slowly, and then they start introducing moisture, water, that really is converted to steam very quickly, and reconditioning the wood. And why this is done, and it's done very slowly, is so that they can reintroduce the moisture and bring the moisture content to anywhere from 4 to 6 or 7% about. That's really where the desired level is. And all of this modification, again, a 3-stage, I've got a little graphic here that might show it a little bit better. All of this 3-stage system takes the wood and it changes it forever. So this reaction is occurring at the core, at the cellular level. When you think of wood, you can think of it under a microscope as a bunch of soda straws, all together, wrapped together. And the cell wall of those soda straws, if you will, it consists of 3 things: lignin, hemicellulose, and cellulose. At that point in phase 2, where I was mentioning sort of the magic happening, where the moisture is going down to 0%, you are basically evaporating, if you will, or degrading the hemicellulose and the cellulose. Those 2 components are known as sort of the polysaccharides or carbohydrates in the wood. Those are what microorganisms are attracted to. So by basically taking those away, you're now creating a wood that is highly durable, because so many microorganisms, enzymes, insects have lost their food source. So the other exciting part about phase 2 is that a lot of the extractives are removed from the timber. So you will get some resin, but you don't get the extent of resin that you would in just kiln dried lumber, if you will. So the resin has been removed at that point. And then again, stage 3, it's conditioned, and your moisture level is anywhere from 4 to 6, 7%. So what I like to show this factory, it's a very clean factory. It's very organized, very efficient factory. And in fact, 80% of the thermally modified wood process here is run off of geothermal, hydro. So there's very little dependence on fossil fuels to run these facilities. But the other important part here is that we are really checking the quality control. So it's very important that with regard to this particular thermally modified wood, that everything from the minute the wood is coming in as raw material, it's being checked for things like excessive cracking or checking. So those boards get put aside. But likewise, once it comes out of the treatment, we want to ensure that the boards, there's nothing that's created a lot of existence of cracking or checking that would not be aesthetically pretty, so to speak, in the built environment. So ITWA is the International Thermo Wood Association, and we are very, very dialed into ensuring that we meet all the standards and codes set forth by the ITWA. This video, if it works, Bo, I'm not sure. Oh.
I can see it, just can't hear anything.
Okay, it's just music. It's
Okay, cool.
I like to show this video. It's a 20-second video. You saw at the beginning the wood was very blonde. And obviously this has been sped up to a big degree. You see the wood has gone in. When it comes out, it's a really nice honey brown color. And that's sort of it. There's not a lot of, you don't have a lot of distillation columns, a lot of piping, a lot of things that you'll see in other plants that require more, they're more, just more to them. This is literally using heat and water to create steam to produce a wood that becomes very durable and stable. So where is the thermally modified wood going in the future? We see it as very bright, very promising. We are looking at things with like CLT, so cross-laminated timber. We're looking at actually just glue laminated beams out of thermally modified wood. They found that there is less carbon emissions. There's less noise on a job site using wood than the old steel and concrete. So we do see a really good future for this. And I feel like everybody on this call has probably in some way or another already been hearing about CLT and mass timber construction practices. I'd like to put this photograph in here of this building in it's in Milwaukee, Wisconsin. So it basically at this point has the distinction of being the tallest CLT hybrid wood building at 284 feet with 25 stories. We did in the US, this particular firm and building beat out a building in Norway here recently. I think it was the last year or so, but not to be undone. There are others globally that will probably surpass this, and you may be seeing that in the coming year or years. But I just think it's wonderful to know thermally modified wood is here to stay, and there's a lot of promise for it in all sorts of different types of applications in the future. When we talk about thermally modified wood sourcing, for this particular discussion, we're using the 4 species that we know work and work really well. And there's a reason why a lot of these species work, and we can get into that. But there's something called AIA-approved, there's ash, character pine, and clear pine. And we'll go through each one of those. Each one of these, by the way, is all being sustainably sourced. So we are only sourcing our wood from very well managed forests. And we use third-party validation services such as FSC or PEFC. So AIA-approved, I've got to say, this is one of my favorites. I am more familiar with the other species, but because this species is it is a hardwood, but it's a softer hardwood, it actually takes the process really well. What I found is that this is an extremely light hardwood, so it becomes one of these wood species that's just great for soffit or sealing. And because there's no off-gassing or anything leaching that's dangerous, no VOCs in this, you can use this wood interior and exterior. You will not, you won't hurt the indoor environment, and certainly the design trend that I see where we're carrying the indoors outdoors. A lot of people like to carry their ceiling look from the inside of the, if residential, for instance, from the interior to the exterior. But I've also seen some commercial applications in restaurants that are doing the same. So this is such a great product for that. Ash, which many of you may be familiar with, is a hardwood, and it's really basically it's really known around the northern part of the U.S., northeastern part. It's great because it can be used in decking. It can be used, I've seen some people make some furniture benches out of it because of it has a little bit heavier weight to it. The density is a little bit more than the others. But it likewise, it can be used as, I've seen people use it as rain screen and that. So ash is another one of my favorites. Has a little bit of a darker look, a little bit more medium brown versus the AIUs, as you can see. The character pine, or Scandinavian pine, as we like to know, will have a little bit more reddish brown. It does have those beautiful butterfly character marks, if you will. And again, this is one of those that I love as an interior wall or even exterior wall, carrying it outside, ceiling. And we have seen a lot of the sort of Airbnb areas, the rustic areas. There's some place close to me called Broken Bow, Oklahoma, and it's becoming a destination place, getaway, and they're using a lot of it, the character type woods, on some of the Airbnb homes that are being built there. But this is one of my favorite as well. I was in a restaurant recently, and they had it when you're walking in to order. It's sort of where you sort of make your own bowl, if you will, and where the menu was, the backdrop was this wood. So I just love it for any interior and exterior use as well. Last but not least, we have our clear pine. Now, the difference between this pine and this pine, as you can see, this has the character in it. The clear pine really basically is being pruned from the time it's a 3-foot high tree all the way up to about a 28-year growth. So they're pruning it from its very early origins to the time that they're getting ready to harvest it for use. The other interesting thing about this is they are able to, for every tree that's harvested, they are able to replant 2 in its place. And we do know that, and we'll get into this in the sustainability part, but we do know that trees suck in carbon dioxide. Sorry, guys, I will apologize ahead of time. I do have dogs. They were supposed to be in a separate room. I'm going to get them moved right now before they start barking. But the trees grow very quickly, 28 years from sapling to sawmill, as they say. So within those 28 years, they are absorbing a lot of CO2. So a tree's purpose, typically, it will breathe out oxygen and suck in CO2. I have a dear friend of mine, and we'll discuss him in a future slide. He used to hold a piece of wood in front of him and say, 50% of this board that I'm holding rather, is CO2. So if you think in terms of that, wood is really the world's most renewable resource. You might all be saying, all of this is great, Lisa. I'm really learning a lot about how thermally modified wood is made. I'm learning about the species, but why? This is where I love this part, because this is the reason why I'm going through this. This is why I'm telling you that this is a great product to consider for sorry, there they go, for future design. And that's the main benefits. You've got dimensional stability, you've got durability, it's very moisture resistant. And in one of the species, the clear pine, there's added fire resistance. In the clear pine, there's termite resistance added. And then last but not least, the sustainability portion of this. So in the dimensional stability part, remember when I talked about wood being soda straws, and the cell wall has the hemicellulose, the cellulose, and the lignin. Well, when it's heated to those high temps and the hemicellulose is sort of evaporated, that also helps control the dimensional stability of the wood. So it won't be absorbing moisture in it and retracting the moisture out, so you don't get wood expansion and contraction. So therefore the wood is more dimensionally stable. Coatings tend to last longer because the reason coatings fail on wood is because it expands and contracts, expands and contracts. Well, if we've changed that now and we've made a wood that's more dimensionally stable, you now have coatings that are more stable. Doesn't really matter where this wood is placed. It can be sold into Miami, for instance. We have a lot of projects in Miami. It can be sold into Ontario, Toronto. I've had a lot of people ask me, what about Canada? We get really cold winters here. Because we've changed the wood structure and it's more stable and it's not attracting and releasing moisture, you've got a wood that's much more stable. So you won't get the warping and cupping that you typically can find with other unstable woods. The durability, this is one of the top reasons when I go around and I do these courses and I ask, what is something that's really important to you? I inevitably get the answer durability, because if I specify this for an exterior project and it starts to rot or decay, I have now replacement costs added to the project, and that the durability of this has been changed again due to the forever sort of chemistry change of the cell wall of that wood. You no longer have microorganisms that are seeking it for food source because you've removed the lignin, you've removed the hemicellulose and the cellulose. So the increased durability, there is an extended warranty that is available because of the fact that they know this wood is lasting a lot longer. And I put this little tag here to remind myself to let you know, look at this building. This is the character of the Scandinavian pine on the side of a building that has been left to gray out. So they chose not to put any sort of coating on it. And this is what will happen with all woods. But certainly thermally modified woods are no different. They will react to moisture in the environment and UV exposure, especially UVA and UVB rays will change that. How fast does that happen is another question I get. It's really dependent on the exposure. Is it southwest facing? Is it north facing? If it's southwest facing, I can tell you with a lot of sun exposure, the change will happen a lot more rapidly. And then we talk about the moisture resistance. Again, moisture is not absorbing into the wood. It's not going to cause that sort of expansion and contraction that you get with normal wood that is sucking in wood, holding it, and then the wood expands, and then when it releases it, the wood contracts, and then you start getting cupping and bowing. You will not see that. I did put this photo in particular for my friends that are in colder climates to show, yes, this wood, it's a commercial apartment complex in a cold environment, and it holds up very nicely. So I talked about the added fire resistance. In our clear pine, there is at the plant level, so this is not an aftermarket treatment. This would come in as treated with the fire resistance in it. Has been shown to meet Class A, where it can meet WUI standards. And for those of you, I'm not sure where you're joining in from, but if you're not familiar with WUI, WUI is the Wildland Urban Interface. I call it a standard or act. It's basically where humans or human developments meet where there's wildland areas. So forestry meets up with, human life. And so you have to be very careful in those areas because as we have all seen the devastating fires out west, what can happen to the homes that are or sort of in this WUI area. So there is on one species, the clear, there is the opportunity where this meets the WUI standard on that one. The other species meet the ASTM E84 Class B. Termite resistance. I changed this photo because typically I do these webinars at lunchtime, and I did have a termite actually on the board before in a photo, and I thought, you know, people might be eating lunch and might not really enjoy that photo, so I took it off. But because, again, think of the cellulose and hemicellulose as sugars or polysaccharides. That's to just repeat again, this is what insects and microorganisms like to feed off of and attack. Certainly no different for termites. There are added termite protectants that can help keep termites at bay on 3 of the species. On the clear pine, again, it does come in with an already added termite resistant product in it that they won't attack it. So the favorite part of the benefits for me is something really near and dear to my heart, is the sustainability portion. Again, if you talk this wood from beginning to end of life, it is very closely watched for its sustainability. And that goes from just choosing the wood, from where are we sourcing it from, and ensuring that those are all very well managed, all legal and certified, and certainly validated by third party, to the manufacturing process. Remember, we're not bringing in other chemicals. We're not bringing in, it is literally just heat and steam. So it does help to reduce that environment footprint, so to speak. And the carbon sequestration, we talked about, if you've got a wood product that you're using in the environment, and you know that its service life is 25 plus years, which all of this thermally modified wood is, you can find that you will be sequestering carbon for the life of that product. So for 25 plus years, you're sequestering carbon. And then, of course, for the end of life, it is just wood at the end of the day with 4 to 6% moisture. So it can be repurposed, reused, recycled. You can do anything with this wood and not have fear of any sort of leaching or off-gassing of anything coming out. So when we go through the environmental benefits, I like to talk about, again, the environmental credentials from the selection to the end of the life, and then the biophilic credentials. So we know that the material selection contributes to this by sourcing the woods that are from well-managed plantation forest, sourcing woods that are very fast growing, and typically the younger the tree, the more CO2 it sucks in. As trees get older, they stop really sucking in as much. So we know, at least with the clear pine that we are sourcing, 28 years, it is really sequestering a lot of carbon in that. And then you have it in the built environment for its 25 plus additional years. So I like to show this. Bo, I think you probably are not too far from here, but this is the Liberty Bell in Philadelphia. And when we talk about wood and the longevity of wood, think of this particular yoke that was produced for this Liberty Bell was harvested in the 1770s at some point, but it is still the same yoke today. So in 2024, some 250 years later, you still have the wood that was used to create the yoke for this Liberty Bell. So think about the carbon that's been stored in that piece. But it's just an example I like to show, you know, and just talk about the longevity of wood. Biophilic design. I'm sure many of you are very familiar with biophilic design, the term, and biophilia. I think you know, what I had, since I have been working with biophilia and biophilic design, and certainly with this product, you know, my studies, I think it was Edwin Owen back in the 70s and 80s sort of coined the term. And he really was talking about it being where the human connection and you know, nature connection intertwined. I think he wrote a book in the 80s, I believe it was, termed Biophilia. But what I like to push forward even closer is Stephen Kellert, who was a professor at Yale University. He was part of the School of Forestry and Environmental Studies. He really took the biophilia a step further and really started pushing it toward design and biophilic design. And his whole idea was to connect humans, us, back to nature so that we could promote a better living, working environment that helps with our productivity and creativity. This particular photo is from Croon Hall at Yale, and this was Professor Kellert's, something that he helped to push forward, where this building, you can see they use a lot of light, they used a lot of wood, especially. That's the big point I want to show, is that the use of the wood interior. And so he really did sort of practice what he spoke about by helping get this building move forward. So Rick Fredrizzi, who is a former CEO and is certainly one of the founding persons, chairman of the USGBC, has a quote, and he talks about the why. Again, you know, talking to you earlier about, you know, why thermally modified wood. Well, I think this is one of those that sums it up very much so. And it's just about, you know, we can all design and design beautiful things, but what is the why, and what are we doing to help for the next generation and certainly the future? And for me, that was really important, has always been the why of wood and thermally modified wood. There are a lot of principles of biophilic design. I typically just talk about these top three: nature integration, prospect and refuge, multisensory experience. And you can read basically each one of them, where nature is just incorporating all those natural elements. Prospect is interesting to me because it's sort of creating spaces that provide both the expansive views, but also a sort of cozy sheltered area. But also all of this to help fulfill our basic human needs for safety and exploration, all while using products that are innately natural for us. And then the multisensory is another of my favorite, because you use all of your senses really to feel the touch of the textures, the smell of wood, you know, the colors, the different colors, and just the different sounds, and the fact that wood is has a great acoustic property to it. So with natural integration, this sort of self-explanatory. I mean, let's incorporate some more natural light in our workspaces, in our home life, in our schools. It's really important to do that. And while we're doing that, incorporate something natural along the lines of wood, putting plants around, you know, all of those things to enhance that interior use. Just really integrating the natural world outside to our interior space. Prospect and refuge, we talked about, again, it being a great acoustic property. So you have it as a nice sound barrier where you can sort of, you know, still have the outside, but not hear maybe so much of the outside noise, if you will. And it also contributes to better environmental air quality, because you're literally minimizing any sort of VOC emissions by using thermally modified wood, because again, it's just wood and moisture or water, if you will. The multi-sensory experience, this is another one of my favorite photographs where they are using wood in a daycare. And what better natural element but the world's most renewable resource and a natural thermally modified wood, but to put it in a daycare where children are. Children are constantly touching, they're looking, they're smelling, they're able to connect with this much better. And in fact, I think, and not I think, I know, excuse me, there have been studies, and anybody's interested, I find a lot of these really fascinating. There was a study in Japan that is literally showing the effects of using wood and more natural elements on the interior of schools, on the interior of office spaces, that children's test scores have been shown to rise. Workers, our productivity, we tend to do better when we're surrounded more by natural elements. So I can't think of a better thing to use for interior wall space than something natural like wood. With this slide comes great honor. I have the honor to know a friend of mine, Criswell Davis. He was a hardwood expert. He did a TED Talk on biophilia and biophilic design. Anyone is interested, I'm happy to send you the link to it. The reason I like to talk about Criswell is because he experienced literally the difference in visiting a place where it was just white walls and stainless steel versus a place that had more natural light, plant life, and wood in its interior. Criswell had developed cancer, and he was going to his hospital that to get treatments, that was in a room, very sterile, as he puts it. It's like he said, Lisa, with the white walls and the stainless steel. But he had changed hospitals, had gone somewhere else for treatments, and they had been introducing in this particular hospital in their treatment rooms the sound of waterfall. They had waterfalls, they had plants, he was surrounded by wood. And he said that his sensory factors, he felt differently. He said, I can tell you that this is true. Your sensories really do absorb the natural and of nature products when you're indoors versus what we're all used to. So Criswell had gone in remission from his cancer, was doing really well, and then unfortunately, due to other complications, passed away a couple of years ago. But I will continue to speak on his behalf on the importance of biophilic design in our design built environment nowadays. So again, just to review the benefits of biophilic design, I think you guys, have probably learned that I'm very passionate about this part. It can reduce stress. They have proven it in tests. It improves your mood and it enhances your cognitive function. It's sustainable. And again, we talk about the productivity and creativity of it all. And likewise, it helps create a more inviting space for interaction and collaboration. So when we talk about the applications, I'll just go through some of these to give you an idea. There's that beautiful Scandinavian pine, character pine, if you will. This is the ash. I love this because they were building some tiny homes and they clad it with the ash product. Love that look. Then you can see just, some horizontal design there, rain screens. Again, the character, it's really getting popular. And I like to show this one. Someone asked in the last training I did, can I get somebody to get an even more up close photo of this? And I will certainly do that. The reason I like to show it is because it's at a 45-degree miter. And when we talk dimensional stability, you're able to use this wood at a 45-degree miter and not be concerned about movement, so you can sort of hide it, or excuse me, you don't have to hide it by using exterior trim. And that is a nice school that you can see that's using, this is actually not grayed out yet. This is using a light, it's called a light gray stain that they used on this particular building. Ceilings and soffits, I was talking about the AUs. Decking, we'll just kind of go through these because I'm sure time is up. Oh, I'm sorry, Bo, I just clicked off of a poll that just came up. Apologize.
That's okay. You can click out of that.
Okay. And nice swimming pool. Water looks great about now with the heat. And here's some interior spaces that I love to show. Look at that. Just beautiful. And other uses, garage doors, fencing. This is another really great design. The horizontal fencing seems to be really popular now. Front door. And then when we talk about the best practices for thermally modified wood, I will say you don't have to store thermally modified wood and climate controlled. It just needs to be undercover until it's out in its element. I do recommend, let's say, you get the wood on a job, or the contractor gets the wood on the job site. I do recommend letting the wood, acclimate to the weather wherever it's at for 24, 48 hours, even better, just to acclimate, and then it's ready for install. It's just so that the wood, because it's a natural product, it's just getting used to its environment. There's really no special instructions for installation, other than I would say to please pre-drill, and we'll talk about that on another slide, only because thermally modified wood is a lower moisture content than many other woods. So there's where we talk about using stainless steel fasteners. The wood doesn't require it really because it doesn't have anything that's going to react. However, fasteners that are not stainless steel, especially in coastal areas, they can corrode. And what would happen then is they may cause just some ugly marking on the wood. It's not the wood, but it's the fastener. So I always say, use stainless steel and you'll be great. Best to pre-drill to avoid any splitting. So I still recommend pre-drilling. The clip systems, there's a lot of clip systems that are out on the marketplace today. Those definitely can be used with the decking and cladding that we've seen. Finishing, we have found that penetrating oils, mineral oils that are mineral oil based work extremely well with thermally modified wood. Water-based likewise work. But if you don't want to finish the wood, it will just gray out. It will take time. Depending on where you are at, it may take more time. Southern hemisphere may take less time than northern hemisphere just because of the sun exposure. This concludes this portion. I just want to thank everybody for listening to this course. I think I would ask that you look next projects, consider maybe thermally modified wood, because I think we do elevate the quality of our built environment, and it does and will help for future generations to come. So thank you all very much for your attention.
Awesome. Thank you so much, Lisa. That was a great presentation. It looks like we do have a question, and we have a few more moments. If any folks have some additional questions, feel free to throw them in the Q&A now. We can get to some of those live.
Okay.
All right, starting off with, is wood a viable option in hospitals and elderly homes, or would it hold bacteria? Is thermally modified wood better for those concerns?
Thermally modified wood, again, microorganisms are attracted to moisture and the hemicellulose and cellulose of the wood, because those have pretty much been degraded and evaporated out. It's not going to hold bacteria that I know of. As far as mold, everything attracts mold, and we've proven it out. We've shown where mold is grown on glass. There are treatments that you can put. Now, this would be probably job site if they wanted to put something on it to inhibit mold growth. But for interior wise, we have not seen any issues with sort of, I guess, any issues with biological growth that are causing health concerns.
Awesome. All right, and then does this wood still splinter without treatment?
That's a great question. So with the thermally modified wood, you're stabilizing it so you don't get what they call grain raise like you do with typical woods. So with the thermally modified woods, you're reducing the effect of splintering, if you will. But is the question, if it's not thermally modified, does it splinter, just the wood in general, or?
It just says, does this would still splinter without treatment? So Kaylin, if you have any clarifications there, feel free to throw them in the Q&A as well. All right, looks like we've just got some, oh, one more came in. All right, if you apply any finish oil, how often would you have to reapply to avoid the gray look?
That is a great question. And let me say this too. When you apply a finish oil, it's really important that you apply it with a color tone, a color to it, because just a clear finish oil, by the way, will not inhibit UVA or UVB. Those react off reflectance from colors. So I would suggest always putting, even if it's a color closely related to the wood tone that you've got, put some sort of color in it. We have been told in southern areas, the sun, you know how the sun can be just brutal. We've had people say that in a year and a half, they're having to on southwest facing, they're having to reapply. I've had other people say, no, it's about every 3 years. And that's more northern, more Midwest type areas. But so there will become a maintenance cycle required.
Mm-hmm. Okay, great. Got a few more coming in, so let's see how many we can get through here. Can thermally modified wood be used for exterior feature walls of a type 1 construction structure?
That I might have to get clarification on. I'm not familiar with a type 1 construction.
Okay, cool.
So
if
will you
whoever
send it to me, Bo, after? Will I be able to? And
We'll you too.
Yes. Okay. Thank you. Whoever addressed that to me, I'll make sure to get back to you.
Yes, definitely. And there will be a quick post-event survey, so whoever asked that question, if you want to add additional details there, you can as well. All right, 2 minutes. Let's see if we can get to this last one. From Jerry, remember when several playgrounds were constructed across the country made of pressure-treated wood and they all had to be torn down because of VOCs? Would thermally modified wood have avoided that?
Yes, it would. And that's funny that that's brought up. We were speaking about this earlier, weren't we, Bo? I was talking about the old tree. This is going way back because this has since been banned, except for I think out in the ocean you can still use CCA or pilings and whatnot. But the old treatment that you're referring to was treated with something called CCA, and that was copper, chromium, and arsenic. And yes, that was a treatment. It leached out. It didn't even go to the surface core. Thermally modified products are literally heated, and the heat exchange along with the temperature control and removing the oxygen, it's changing the wood at the cellular level. And then reintroducing moisture or water to steam. That's it. So there's nothing that's off gassing out of the wood. It's even removing a lot of the extractives. So all wood will contain a little bit of acetic acid, somewhat resin, but it's removing much of that. But acetic acid coming out of the wood is not, at that level, is not harmful. It won't hurt.
Awesome. All right, great. Well, I think that puts us just about at time. We will follow up with any folks whose questions did not get answered today. Lisa will have a record of those so that she can get in touch and give you some more information, clarify anything that might need clarification. Just want to remind everyone as you're heading out today, feel free to grab any of the links from the chat. We've got Helen's meeting link, the link to get in touch with Lisa on Acelab. So Feel free to grab those for future use. And there will be a quick post-event survey. If you can give us some feedback there, that's super helpful for us to keep bringing you content that's relevant to you. And feel free to add any additional questions that you might have to that as well. All right. Thank you so much, everyone who attended today. And thank you for all of the great questions. And Lisa, thank you so much for an excellent presentation.
Thank you, Bo, and thank everyone for attending as well. Thank you.
Have a great day. Bye.
Okay, bye.